Hi boys and girls, welcome to my YouTube channel. So today we are going to discuss about the superposition theorem. Okay, in the previous video I told you that we have something like 8-9 theorems are there, but in this course we are going to study 6 theorems. So the superposition is one of the 6 theorems. So the superposition theorem states that the response in a circuit with multiple sources is given by the algebraic sum of responses due to individual sources acting alone. Okay, the response in a circuit with multiple sources is given by the algebraic sum of responses due to individual sources acting alone. Let's say you have a circuit, okay, and the circuit has many sources. See, the sources can be voltage sources. You know we have voltage sources. The sources can be current sources. Okay, suppose we have a circuit with many sources, maybe voltage and what? And current sources. You want to calculate the current passing through. Suppose you want to calculate the current passing through a resistor in a circuit. Okay, you want to calculate the current passing through a resistor in a circuit. So I am saying you have a circuit with many resistors, many voltage sources, many current sources. Okay, this is the structure of the circuit. But see, you want to calculate the current passing through only one resistor. Okay, you want to calculate the current passing through only one resistor. Okay, so what are you supposed to do? We are going to use the superposition theorem. How? I'm going to get rid of the other sources. I'm going to eliminate the other sources. Okay, and I'm going to remain with one source. Suppose I have 3 sources. Okay, it means 2 I'm going to remove, and I'm going to remain with one source. Then I will be like, if I have this one source, what is the current passing through this resistor? You do the calculations and you note down the answer. In case number 2, I'm going to eliminate the first source and the other one from the 2 that I have eliminated in the first case. Okay, so I'm going to remain with another one source. You do the calculation again. What will be the current? You eliminate the other 2, then you take the third what? The third source. If you have the third source, what will be the current flowing through this resistor? Okay, now you have 3 currents. You sum up the currents. Then only you will be able to calculate the current passing through the resistor due to the what? Due to these sources. I said the sources can be voltage sources and the current sources, the sources can be what? Can be current sources. See. So how are we going to remove the voltage sources and how are we going to remove the current sources? It's not something like you just remove. Okay, and after removing, we are now confused. What is the meaning of this and the like? No. You remove with some laws. Now, see, the voltage sources are short-circuited. So this is how we are going to remove the independent voltage sources. So the independent voltage sources, we are going to short-circuit. What is to short-circuit? To replace the voltage source with a wire, with another, we just replace a branch, a path. Okay, and the independent current sources are open circuited. See, so if this is positive and this is negative, let's say it's 100 volts. You remove this 100 volts and you put a straight line. This is to short circuit. It means what? It means now the voltage is equal to 0. Okay, if you have an independent current source, suppose this is the independent current source, which is 20 amps. This is the independent current source. How are we going to eliminate this independent current source? You are supposed to open circuit. What is to open circuit? This is to open circuit. Okay, so the current sources we are going to open circuit. The voltage sources we are going to short circuit. So if you open circuit the current source, it means what? It means I is equal to 0. So if you open circuit, it means the current is now equal to 0. If you short circuit, it means the voltage is now equal to 0. Okay, this superposition theorem is not applicable to nonlinear network and nonlinear parameters such as power. So you cannot use the superposition theorem directly to find power. It's not possible because power is a nonlinear parameter. Okay, what about in nonlinear networks? You cannot use the superposition theorem in nonlinear networks. So it means what? It is only used with linear networks. Okay, is used with linear networks. Okay, see the importance. I think I uploaded a video. I told you the difference between linear networks and non-linear networks. What is a linear network? What is a non-linear network? Okay, active networks, passive networks. Okay, bilateral networks and unilateral networks. You should know all this. This is the importance now. If you don't know what is a linear network, you'll be like, oh, Cecia is saying what? If you don't know what is a non-linear network, you'll be like, oh, what's going on? Okay, so this superposition theorem is not applicable to non-linear networks and non-linear parameters. It is only applicable to linear networks. Dependent current and voltage sources remain the same. If you have a dependent source, whether it is a current or it is a voltage source, you are not supposed to remove, you are not supposed to eliminate. Dependent sources will remain the same. We'll see in the question. See, dependent voltage sources and these current sources are usually represented with a diamond. Okay, suppose this is positive, negative, and we put an arrow here and write 2 amps. It means this is a dependent current source. If voltage is written here, it means it is a dependent voltage source. Okay, if you have a dependent voltage source, if you have a dependent current source, you are not supposed to eliminate, you are not supposed to remove, you leave them like that. Okay, only these dependent, this is the dependent voltage, and so this is the independent voltage, and this is the independent current. You are supposed to eliminate. Okay, so I'm going to use this diagram to explain the superposition theorem. I'm not going to solve, but I want you to get the sense of the superposition theorem. Okay? See, a diagram is given. Calculate the current passing through the 5 ohm resistor using the superposition theorem. So you are supposed to use the superposition theorem to calculate the current passing through this 5 ohm resistor. Okay, I'm going to say the current passing through this 5 ohm resistor is I. How many sources do you have? 2 sources are there. This is a voltage source and this is a current source. Okay, so it means what? This voltage source is supplying current and part of the current is passing through this 5 ohm resistor. Again, this 20 amp current source is supplying current and part of the current from this current source is also passing through this 5 ohm resistor. Okay, so in order for you to find out the total current passing through this 5 ohm resistor, what are you supposed to do? In order for you to calculate the current passing through this 5 ohm resistor, what are you supposed to do? It means you are supposed to say the current from the 100 volt voltage supply plus the current from the what? From the 20 amp current source. Okay. And in order for us to do this, I am going to open circuit this. And I'm going to remain with this. So if you have this, you can calculate the current passing through this 5 ohm resistor due to this voltage source. This is case number 1. Case number 2, I'm going to leave the current source like this. Okay, ba? And what am I going to do? I am going to short circuit this. Okay, ba? I'm going to short circuit this. Now you can calculate the current passing through this 5 ohm resistor due to what? Due to this 20 amp current source. So I is equal to I is the current passing through this 5 ohm resistor is equal to the current due to the 100 volts voltage source plus the current due to the 20 amp current 20 amp current source. Okay, here we are. This is the value of I. Okay, right? Now in order for you to calculate this, case number 1, you want to calculate the current due to the 100 volt voltage supply. Due to this 100 volt voltage supply. What are you supposed to do? You open circuit the 20 amp current source. Okay? Case number 2. What are you supposed to do? You want to calculate the current due to this 20 amp current source. So what are you supposed to do? You should make this to be equal to 0. So how to make this be equal to 0? You short circuit the 100 volt voltage supply. Here, this is to make this voltage to be equal to 0. This is to make this current to be equal to 0. So in case number 1, you are going to calculate this. In case number 2, you are going to calculate this. Okay, right? So after open circuiting the 20 amp current source now, it means you have this. How are you going to calculate this current now? It means you have to employ mesh analysis, right? You have to employ mesh analysis. Here, if you short circuit this, and you have this. What are you supposed to do? You have the current source, right? If you have the current source, it means you can employ node analysis. Okay, then you can apply node analysis. See, now it's now the combination of the superposition theorem and mesh analysis and node analysis. So you have to think like that. This is the importance now. You should be able to bring all the concepts together. You should be able to bring all the concepts together. That's why we taught you mesh analysis on its own. We taught you node analysis on its own. Now we are combining the three: superposition theorem, either mesh analysis or either you can use node analysis. Anything that you can use. What we want is to calculate the current which is passing through this 5 ohm resistor. Okay. Okay, thank you very much. Have a good day. I will see you in the next class.